Hi everyone. So in this video, we're going to look at finding the regions of loci with complex numbers. Before we work through the examples here, we need to remember three important equations, where the distance between z, which is a general complex number, and a fixed point, the magnitude of this distance forms a circle, where the center is at z1 and the radius is the constant. We also have the magnitude of z minus z1 is equal to the magnitude of z minus z2. And what this tells us is that the distance between a general point and a fixed point, that distance is equal to the same distance between a general point and a different fixed point. And the final property involves the argument, where we have the argument of z minus z1 is equal to an angle theta. And we're going to use these three properties to find the regions in which z can lie within these three statements. Okay, so if we look at example A, what this is telling us is that the distance between a general point on the complex plane z and a fixed point given here, well, this distance must always be less than or equal to 4. So if we say that z1, the fixed point, will be equal to 3 plus 4i, then we can plot this on an Argand diagram. So we have our circle with a center of 3 and 4. So 4 on the imaginary axis, 3 on the real axis. And this circumference tells us all the points that are exactly 4 units away from the center. So then we need to look at what this is telling us. And this is saying that the complex number z must be less than or equal to within 4 units of the center. So I've shaded in green all of them points. Any point in this green area is less than or equal to 4 units from the center of this circle. And the circumference is a full, complete line. This means it can be equal to it. If it was less than 4, then the circumference would be a dashed line. Okay, so Z, the general point, can be anywhere within this shaded region, because these are all less than or equal to 4 units from the center. Okay, so for part B, we're going to use this property where you can see that Z1 will equal 5 and Z2 will equal 9. So now we can plot these 2 points on another Argand diagram. If we plot 5 or Z1 here and Z2, 9 on the real axis, and that'll be there, we'll label this Z1 and Z2. Now what this is telling us is that with general point Z, the distance between that and 5 must be greater than the distance between the same general point and 9. If we have this point here, for instance, well, you can see this is closer to Z1 than it is to Z2. Then this point wouldn't obey this statement. But if we looked at this point, well, this point has a shorter distance to Z2 than it does to Z1. So this point would obey the statement. So what we need to do is find the equidistant path between Z1 and Z2. And this is a perpendicular bisector. But because we're told it has to be greater than and not equal to, we represent this with a dashed line. And you can see that all the points to the right of this line will have a greater distance to Z1 than they do from Z2. Okay? So finally, if we look at question C, we're going to use this statement, and we can see that Z1, the fixed point now, will be positive 4i. So now we need to plot this on an Argand diagram. Now, if we plot Z1, which is at 4i, or 4 on the imaginary axis, then we're told here that the argument must be less than or equal to pi over 4, but greater than 0. And we know the argument always comes from a direction parallel to the real axis. So we've shown this with a dashed line that runs parallel to the real axis. So coming from 0 degrees, the argument will have a limit of pi over 4. And we're told it can be equal to pi over 4. So z could be at any point in this region where the angle here is pi/4 radians. Okay? Okay, so I hope that's given you a clear idea on how we plot regions involving the loci of complex numbers. If you did find that helpful, please like and subscribe, and you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.